Good morning, students. Welcome back. Today we are going to discuss next new topic under the electric current lesson, that is Ohm's law. Ohm's law is the most important topic and concept for your future course subject in physics. Before moving on to the topic, let us first know the important questions under the Ohm's law concept, which can be asked to you in your exam point of view. First one is, what is Ohm's law? What are the materials required? What are the materials required in Ohm's law activity? Write an activity to prove Ohm's law or to show the ratio of V by I is a constant for the conductor. So this is very clear and very important questions under the. So let us move on to the concept now. What is Ohm's law? Ohm's law was given by the Ohm's, a scientist which is very much famous or well known to our physics subject. So let us know that what is Ohm's law, what it says. It says that the potential difference between the end of the conductor is directly proportional to the electric current passing through it at a constant temperature. This is a very important word here, constant temperature. Here it says that in a conductor, if I apply a voltage across this conductor at a constant temperature, he has taken a temperature, surrounding temperature should be constant. You should take a room where the temperature should be constant temperature throughout the activity. If I change the voltage, the current passing across the conductor or the whole circuit should be the same, which should be proportional to the voltage. That is the potential difference. So what is saying that if I increase the voltage increases the current value also. So the increase in voltage increases the current value at the constant temperature. Is it clear? Okay. So moving on to the next one, what he says here, let us write down mathematically what he's saying. Let V be the potential difference between the end of the conductor and I be the current passing through it. So we can write as mathematically V is proportional to I. V is proportional to I. So we can write as V by I is equal to constant. If I remove this proportionality, V should be, here proportionality should be replaced by a constant, any constant here. Here the constant which we give here instead of K, we give the constant as R. Okay. So we can write down as V equal to I into R, where R is a very important term here, that is called resistance. The constant is called as a resistance of the conductor. The resistance of the conductor, as you can see here. It is denoted by R. So V by I equal to R, that is equal to, we can write down as V equal to I into R. So one more important thing, the SI unit of R, that is resistance, is ohm. Okay students, till here it's clear. So moving on to the next one, what is saying here is, symbolically we can write ohms as this symbol. So you can just put a small line, go like this and put like this. So this gives symbol of ohms here. Here is giving as 1 ohm equal to 1 volt by 1 ampere. What does it mean? If I apply 1 volt across giving as 1 ampere, it is defined as 1 ohm. So 1 ohm symbolically written as 1 ohm is equal to 1 volt by 1 ampere. I think this till here it's very clear to you. If it is clear, you can just note down till here. Then we'll move on to the activity and to the next question, which says, what are the materials required in Ohm's law activity? This is mostly asked in the exam for 1 mark question. If it is a state level or CBSE level, the mostly asked question is, what are the materials required in Ohm's law activity? Next one is, write an activity to prove the Ohm's law. So we will discuss later what are the materials required first. So to show the materials, the aim is to show that ratio of V by I is constant for a conductor. For a conductor, if I take a conductor, the ratio of V by I should be constant. Okay. So this is nothing but the Ohm's law. Nothing but stated by Ohm's law. Okay. So the materials required here we need is 5 dry cells, LED, iron spoke, 1.5 volt each. Of dry cells required of 1.5 volt. I'm sorry, could not match it here with the word. The complete sentence is 5 dry cells of 1.5 volt each. Actually, it should be here 5 dry cells of 1.5 volt each. I hope you can understand here. LED, iron spoke, wires, conducting wires are required obviously, ammeter and voltmeter. The use of the ammeter is to check the flow of current, how much amount of current is flowing. Ammeter is a device which tells us how much amount of current is flowing. Voltmeter is a device which tells us how much amount of voltage is flowing across the device. Is it clear to you? Fine. This is the basic circuit of your Ohm's law. Procedure you need to write down by your own. As I explain you here, you can write down in your own words. So what he's saying here is, you need to take a ammeter, we need to take a voltmeter, we need to take an iron spoke here. So this is my iron spoke here. Iron spoke. This is the key here, the voltage applied here. First I am going to take as 1.5 volt. Here we have written it as 1.5 volt of 5 cells we have to take it of 1.5 volt. Okay. 1.5 volt we have to replace it by 1.5, then 1.5, then 1.5 to check change in voltage to the change in the current. Okay. So this is my procedure here. Connect the circuit according to the shown in the figure. Connect, take a iron spoke and connect you can do it by soldering also to connect the voltage, the voltmeter here, the voltmeter is given by V, ammeter is given by A. Voltmeter should be connected in parallel, ammeter should be connected in the series. A key should be there to on and off the circuit, key should be there, and a voltage, that is a battery or cell, you can take it off 1.5 volt first, then switch on the key. Till here it is clear with the procedure, right? So I have taken iron spoke as a conductor here to check whether how much amount of current is being, or voltage and current is being passed. In change in voltage, how much amount of current is being passed with the help of the ammeter and voltmeter, right? So this is the table goes here, that is the voltage table, current table, and I'm going to find the ratio of V by I to check whether the Ohm's law is verified or not. So my aim is to check whether the Ohm's law, to verify the Ohm's law, right? Or to show the ratio of V by I is constant for a conductor, right? So first I am going to take 1.5 volt. I got current value as 1.5 amperes only. As it's a demo example, it's just an example. You can write your own values. If you have done experimentally, you can write experimentally also. So 3 volt is giving me as 3 ampere here. I am going to divide this 2 by and gives a constant of 1 ohms. So you can see here 1 ohm, 1 ohm, 1 ohm and 1 ohm is given, we got here as the same values, which as same values to all the given voltage and current. So I am going to get a constant value here, which shows that my Ohm's law is being verified here. So one more very important thing you have to note down here is the experiment or the activity should be done in a constant temperature only. There should not be any change in the temperature. Otherwise Ohm's law will not be verified here. You are going to get different values of voltage to different values of current here, and then you are going to get the different values of the V by I to the every ratios. I mean to say that we will get a voltmeter and the ammeter the current values, but if I calculate the V by I here, I am not going to get constant values here. So you need to take very carefully here to take a constant temperature while doing this activity. Moving on to the next one. Observation, you can draw a graph here, taking the V by I values, you can draw a graph here, you will get a straight line graph. My observation, write down in your own words. Observation, I observed that the V by I graph is being drawn. I have taken the values and I have drawn a graph here which gives a linear graph here. It gives a linear graph here, which I can say that Ohm's law has been verified here. A conclusion you can write down is, from this experiment we can conclude that the potential difference between the end of the iron spoke is directly proportional to the current passing through it. So this is my conclusion here, which says that potential difference is directly proportional to the current passing through it. Okay, that means the potential difference across this conductor is directly proportional to the current which is passing through this conductor. Okay, that means if I change the potential difference value, the voltage value, I am going to get the change in the current value throughout the circuit. Okay, where the ratio of V by I is always constant. Okay, now you can see here next one more graph here drawn here, that is for the LED, which you have taken one more material here is LED. Now you have to replace this iron spoke with the LED. Replace this iron spoke with a LED here. Replace it with LED and perform the same activity as we have done here. That is, by changing the voltage value, we have to get the current values. Clear? All of you are clear with this concept here? This verifies Ohm's law. You need to draw and write an activity in this way, stepwise. Aim, materials required, procedure, table, observation, conclusion, and you have to draw the graph. Thank you.